Alrighty, moving on to question 5. Now we've got a calculus problem. So like any of these problems, first step, read the question very carefully, look at what variables we've got, and look at what we're trying to solve. So in this case, starting off with the equation here. So we've got an equation for the volume related to the radius and the height. Now if we look at our diagram here as well, we also know that the height is equal to twice the diameter. So let's start off with this expression here. So differentiating with respect to t, and what I'm going to do here, rather than keeping r there, I'm going to use the fact that the diameter is twice the height, therefore the radius must equal the height there. So we're going to substitute or replace in this formula the r with h. So we've actually got h cubed. So what we're actually going to use here is we're going to use the fact that v is equal to a third pi h cubed. So therefore, differentiating h cubed with respect to t, we get 3h squared dh dt. So using the chain rule. Simplifying this, we get obviously the 3 is going to cancel each other out, so we end up with pi h squared dh dt. So we'll put chain rule next to this one here. Okay, so that's our first part. So now we're going to use this differential equation that we've derived here to then work out at what rate the diameter is changing at a certain time. So we've got a number of variables we want to work out. So d is always equal to twice the height. So it's going to be 2 times 10. Height we know is 10 meters. And we also know that dv dt is always set at 30 cubic meters per minute. So rearranging this formula now, we can get that dh dt is going to be dv dt divided by pi times dh dt, which is times by h squared, sorry, and h is 10, so times by 10 squared. Which, if we then calculate this, is going to be 0.0. Okay, so that gives us what the rate at which the height is changing, but we're not actually asked to work that out. We're asked to work out at what rate the diameter is changing. So we're actually being asked to work out what dd dt is. And again, we can use the fact that d is equal to twice the height there, and so it's going to be twice the rate of change of the height, 2 times 0.0955, which, when we do our calculations, is 0.19 meters per minute. Okay, and that pretty well wraps up question 5.